So we're going to start with the kinematic equation, just linear, d equals v naught t plus 1/2 at squared. For the dropping roll, it's going to be h1 as d, and v naught is going to be 0 because it's dropping, so that term cancels, and then 1/2 gt squared since g is the only acceleration. And for the unrolling roll, h2 equals 1/2 at squared since we don't know the acceleration for this one. So if we divide those two equations, we get h1 over h2 equals 1/2 gt squared over 1/2 at squared. So h1 over h2 equals g over a because the 1/2s cancel, and t is going to be the same for both, so they cancel as well. Next, we're going to have to find what A is, but first we need the rotational inertia for the unrolling roll, and we're going to use the parallel axis theorem because it's not rotating about the center, it's rotating about the edge. So that is I equals I center of mass plus mh squared, and the rotational inertia about the center of mass for a ring is 1/2 m times radius of the inside squared plus radius of the outside squared. So that leaves us with I equals 1/2 m times radius of the inside squared plus radius of the outside squared plus m times radius of the outside squared. And we simplify that to get I equals 1/2 m times radius of the inside squared plus 3 radius of the outside squared. Next, we're going to use Newton's second law for rotational bodies. Torque equals I alpha, and torque also equals Fr, and the only force applying the torque is the force of gravity, so F equals mg. Alpha equals torque over I, which is equal to Fr over I, and F equals mg, so it equals mgr over I. Then we plug in our I that we just found, so alpha equals mgr of the outside over 1/2 m times radius of the inside squared plus 3 radius of the outside squared. So we simplify that and get alpha equals 2gr of the outside squared, or not squared, sorry, over radius of the inside squared plus 3 radius of the outside squared. And a equals alpha times r, so a equals 2gr of the outside squared now over radius of the inside squared plus 3 radius of the outside squared. So next we go back to our h1 over h2 equals g over a, and we plug in the a that we just found. So h1 over h2 equals g over 2gr of the outside squared over radius of the inside squared plus 3 radius of the outside squared. And we begin to simplify that. We get h1 over h2 equals r of the inside squared plus 3 radius of the outside squared over 2 radius of the outside squared. So h1 over h2 equals 3 over 2 plus radius of the inside squared plus 2 over 2 radius of the outside squared. So for the rolls that we're going to be using, in SI units, the radii are 0.073025 meters for the outside and 0.015875 meters for the inside. So we plug those radii in for our h1 over h2. So we get h1 over h2 equals 3 over 2 plus 0.015875 squared over 2 times 0.073025 squared. So our ratio comes out to be 1.5236. So we can set our h1 to be anything we want. We chose 1.5 meters. So 1.5 over h2 equals 1.5236. And then we solve that for h2 and we get 0.984 meters.